Going to run through several different examples, all right, just to make sure you've got everything you need. Obviously we're recording video, so you've got this for after. Okay, so what we are talking about is we are talking about the product, okay? The product of two things, okay? And we are talking about things of the form A plus B times C plus D. You've been doing it a lot, okay? So just to explain where it comes from, just in case anyone hasn't quite picked up on it yet. If I do the product of something, let's say I do the product of 6 and 5. What's the answer? 30. Okay. Now I can rewrite this. All right. So I can do it's 6 times 3 plus 2. That should still equal what? 30. And how do we make sure, if we've split up the 5 into 3 plus 2, how do we make sure we still do 30? We still get 30. Yeah, so we have to make sure that we do 6 times the 3 plus 6 times the 2. Okay? So that's when we were expanding a single set of brackets. We did it like that. All right? And it makes sense because I've got 6 times 5, 6 multiplied by 5, 6 lots of 5. And if I split the 5, I've still got to have 6 lots of those parts. So, for instance, if I did 6 lots of 1 plus 3 plus 1. Actually, I'll change that. Sorry. Make it a little bit. 1 plus 2 plus 2. Is that still the same thing? Is that not 6 times 5 still? Yeah? So the answer is still going to be 30. So how do I make sure I do it? I have to have 6 lots of the 1 plus 6 lots of the 2 plus 6 lots of the other 2. Yeah? So I'm expanding 6 lots of 1, 6 lots of the 2, and 6 lots of the final 2. So I'm doing whatever's on the outside by everything on the inside. And can you see how that will always give me the answer 30? Yeah? Because I must have 6 lots of everything. The fact that I've split up the 5, I still want 6 lots of everything. All right? Now, what we're looking at then is what happens if I split up the 6 as well. So what if I, instead of 6 times 5 or 6 times, what if I did 2 plus 4, okay, lots of 3 plus 2? That is still 6 times 5, and the answer has to be 30. Okay? So how do I make sure I get that? Nick?
4 times 3 4 times 3 plus 4 times 3, 4 times 3 plus 2 times 3 plus 2 times 3 plus 2.
Yeah. So I need to make sure everything on the left-hand side bracket is multiplied by everything on the right-hand bracket. Makes sense. It's got to be 6 times 5. All right? Now, one way we do that is we can use ways to remember it. And one way people do it is they say, well, we've got to do 2 times the 3. So what I can say is I'm going to multiply the 2 first parts together. Okay? Make sense, the 2 first numbers? So I've got 2 lots of the 3, but then I've also got 2 lots of the 2. Okay? So I can say I do the outside numbers. Okay? Does that make sense? I've got 2 lots of 3, 2 lots of 2. Is that not like having 2 lots of 5 already sorted, yeah? Is that clear with everyone? Then I will do, well, I've got to do 4 lots of 3. 4 lots of 3 is the inside numbers. and then I've got to do 4 lots of the 2, which is the last numbers. Okay. Now, if you take those first letters, you'll see it spells out
Foil.
foil, which a lot of people, that's how they remember. They say, oh, I'm going to foil it, and they just mean they expand the brackets. All right. Now, you might say, well, why do I bother? I would just do 2 plus 4, make it 6, and I would do 3 plus 2 and make it 5, and do 6 times 5, wouldn't you? All right. So why are we learning this technique? Well, we're learning it for when we don't know what those numbers are yet. All right. So you've been doing it. We know we take a number, we add something to it, and I multiply that by the number, and I add 4 to it. Okay. So I don't know what these two numbers are going to be. If I said to you x is 7, what would it become? 10 times 11, which would be 110. But that's only any good if I tell you that x is 7. What if x isn't 7? What if it's something else? Well, this is what you've been doing. So we expand these brackets and we say x times x, so we do the firsts. X times x gives me x squared. We do the outside, so we do x times 4 gives me, so x times positive 4 gives me positive 4x. We do the inside, so positive 3 times x, so positive 3x, and then we do the lasts, so positive 3 times positive 4 gives me positive 12. And then because of what you've been doing before, we collect like terms, these ones in the middle, and we end up with x squared plus, well, you'll notice that we're doing 4 plus 3, 4 plus 3. So that's the shortcut we're trying to use. X plus 7x plus 12, which is 4 times 3, because that's what we did at the end, 3 times the 4. All right? Now that should also be the case if I use this one instead of this one. Let's say x equals 7. Can I show that the answer is still 110? How? How can I use this one to show that if x is 7, I still get 110? Aisha?
Well, you put 7 in x.
Yeah, so we would have 7 squared plus 7 times 7, which is another 7 squared, plus 12. So that would be 49 plus 49 plus 12, and that does equal?
110.
So we're laughing. We're happy. Now this, just to let you know, so you can add it to your notes, so we'll talk about, this is called factorized form. Do you know why? Any idea? What does the word factor mean? Well, if I say to you, what are the factors? You're right. But if I say to you, factors of 7, what are you looking for? 2 numbers that not go into, but multiply. Exactly. So factors of 11, or I'm picking prime numbers, factors of 9 are?
3.
So 3, because you do 3 times 3, or 3 multiplied by 3. 9 multiplied by 1. Factors of 36 are? 6 times 6. 3 times 12. 2 times 18.
Yeah.
Pardon? 36 times 1. 9 times 4. That's the one normally people forget. So we can find them in pairs, but factors, you look at numbers that are multiplied together. So do you notice how here, look, it's this one multiplied by this one. So it's like putting two factors together, multiplying it together. This is not factorised form because there are three things that are added together. Okay? So this we would call standard form. Okay? Each one has specific uses which you'll see in the future. Right? How many terms does the standard form have?
3.
3. How many terms does factorised form have?
1, 2, 4.
3. 2.
2.
Because
So x plus 3 is a term, and so on, yeah? Okay? Alright, so we've got that sorted. You've been doing that anyway, haven't you? That's easy enough. So what I just wanted to explain a few things, where it comes from, why we're doing it. It's very important that you understand it's something multiplied by something else. You'll notice on the board to the left, all that stuff that's there. That's what I've just been doing with my M5s, right? They need this to enable them to do everything else. So you will need these skills to be able to solve for different parts on different types of graphs and things like that. We're not going to worry about it yet, probably not this year, but next year definitely. So what I'm going to do, let's just have a look at a couple of other examples then, just to check that you're okay before I let you go on, Sal. So what if I said to you, expand x plus 3, x minus 7. Ooh. Anyone want to tell me the answer straight away? Anyone?
X squared plus 7x minus 7x
Minus 7x
plus
plus
3x. Oh yeah, and then x squared.
Nope, you haven't finished yet.
Oh.
So we've
yeah.
done
Oh yeah.
firsts,
Then we've done
we did
7,
outsides, insides, so you're missing
3. So that's negative 21.
negative 21. Okay? And we simplify and we get x squared
Minus 4x minus 21.
Alright? I'm going to ask you to notice anything that could potentially help you in the future once we've done a few of these examples. So pay attention to what's happening. Okay. So the next one I'm going to say is we've got a minus 2 multiplied by a plus 5. Would anyone like to go straight to the answer? Is it gonna?
Okay, so a squared
A squared
plus 5a
plus 5a
minus 2a minus 10.
minus 10. If we collect that together, we end up with
A squared plus 3a minus 10.
alright. Another one for us to do. So if I said to you we've got h minus 3 multiplied by h minus 6. Someone did it. Thank you, Daniel. Nick, would you like to go?
H squared
H squared
minus 3h plus minus
plus 18. So when we collect it together, we end up with h squared
minus 3h
remember, I've got collect like terms, so I've got minus 3h minus another 6h is minus 9h plus 18. Now, what I want you to notice is something we're going to use in the future, which is, do you notice when both brackets have got a plus sign? I'll come back to it in a minute if you're still writing notes. Both brackets have got a positive. What do you notice about the two terms here? They're both positive. This one, both of these have a positive and a negative. What do you notice about the two terms?
negative.
Well, these are both negative,
That was
but this one's positive and negative. Any connections made there? So if I've got a positive and a negative, it looks like that the final term is always going to be
Negative.
negative, because a positive multiplied by a negative is negative. Now, what pattern can you notice about, well, this one's negative, but this one's positive? Any statement that you can make? No, don't spot anything. Go on, Izzy.
Well, the first bracket is positive and the second one's negative in the first one, and then the second one, the first bracket's a negative.
I did do it like that. I didn't mean to necessarily. Do you accept that multiplication can happen either way round? Are you happy that the brackets could be either way round?
Yes.
So it's not going to be that then, because I could have put the other bracket first. But I do get what I should have noticed that myself. Right, I'm not going to worry about it at the moment. We'll come back. I might make you think about it. But what do you notice about the final one then? Both negatives, and we end up with a one negative, one positive. Okay? So, just out of interest then, if I said to you, actually, I'm going to give you the answer, I want you to come up with the question. So if I said to you, I've got y squared plus 6y and then plus 8. If I asked you what are the two brackets, have a think about it, everyone, just for a couple of seconds. Those of you who've got your hands up, great. But Thomas, you're not thinking about it, you're just colouring in squares in your book. Come on. Oh, go on then.
Would it be y plus 2 in third, and then y plus 4?
What do you reckon, Daniel?
Yeah.
Yeah, Nick, you going to say? You agree?
Well, how would you get 6?
Actually, yeah.
Oh, wait, yeah,
No, 2
no.
times 4.
Yeah.
And then 4.
No, yeah, but how would you get 6?
Yeah.
Nick?
Y plus 3, and then y.
Alright, stop you there. Oh, you're right. He's right. Not remember, it was 2 plus 4 to make 6, and 2 times 4 to make the 8. Yeah. This, we're not going to worry too much at the moment. This is called factorising. This is where we go backwards, okay? But that's why I'm trying to get you to think about how to do it quicker, because when we want to factorise, those are the rules we want to work on. Okay, just a couple more examples then before I let you get on. I just want to check, how are you if we have something like 2b plus 1 multiplied by 3b minus 2. Nothing changes, but it's not so easy to do it in your head, but on paper it's still fine. So we would go through again. Make sure, if we think about, we have to have everything. Foil, so firsts are 2b times 3b gives me
6b.
Square.
6b squared. This was the stuff we were doing on our thing. The outsides then, 2b times negative 2 is negative 4b. Insides, 1, so positive 1 times 3b is, lasts are positive 1 times negative 2 is, if I collect my like terms again, I end up with,
Negative 1.
so I just write negative b, not 1, I don't put the 1. Minus 2. Okay? So that's all we have to do, nothing different, but we have to be aware if if what's in front of the letter is not just a 1, we have to multiply that number again. So that's why we did that stuff on expanding things before. Okay? And 2 more examples so that you can follow these through. If I said to you 3 minus y plus 2, again, we've got a method, use it. So we do. First
3y.
is 3 times y gives me
3y.
3y. Outside.
6.
So 3 times 2 gives me positive 6. Insides.
Negative y squared.
So it's minus y squared. Lasts.
Y.
Minus y times positive 2 is negative 2y. Now it's just not in as nice an order, but we still collect like terms. We did that before, you should be happy enough. What do we start with? We start with the,
Negative y squared.
so we've got negative y squared. Then we've got 3y, subtract 2y is
Y
plus a y
plus 6.
plus 6. Okay? One more. 5 minus x squared. We already talked about one like this.
Oh, yeah.
What is it not?
5 minus x times 2.
True. This also, so I gave you an example of what people do. It's not.
It's not 25.
Yeah, so I'm thinking it's not 5 squared minus x squared, which is 25 minus x squared, is it? It's definitely not that. That's a big exclamation. That's what a lot of people do. It's not that. What do I have to do if I've got something squared? Exactly. No, no. Multiply it by itself. Exactly the same thing
I
again.
know that.
When you square something, you multiply by itself.
Yeah.
Right? What happens now?
5.
First, 5 times 5 is
25.
outsides,
5x.
negative 5x, good. Insides,
5x. Negative 5x.
negative 5x. Lasts is
X
squared.
X negative.
positive,
Positive x squared.
Oh, because
because it's negative times negative. So then we rearrange and we write it
X
x
squared
squared.
minus 10x plus 25.
Yeah, that's right. Okie doke. So you now you've got lots to do. So starting on page 143, okay, you've got exercise 7F. Right, question 1, question 2, question 3. All right. So going on to page 144.
What if we've already done it?
You've already done it, right? If you're done with all of those, which you're probably not, because I'm sure there's some that you can go back to, right? Then you can carry on and go on to perfect square expansion and the difference of two squares, but we will need to talk about them specifically. But I don't think you've done...
No, I've done all of one, but not...
If you've done all of one, go on and do question 2 and 3. That's fine. Okay? We've only got, 10 more minutes now. Aisha.